Hey everyone, welcome to another video. So today we are building up on the area of a circle, and we're going to look a little bit more closely at what happens when we cut our circle up into smaller pieces if we don't have a full circle. Now, we touched on this a little bit in the video on arc length, and we're going to apply a lot of the same principles to the idea of thinking of areas of sectors. Now, once again, we want to first think about what we've already learnt about the area of a circle. And the formula that we came up with in the previous video on this topic was that the area of the circle equals to pi times the radius all squared. Now, if I draw up a circle, this is the formula for a whole circle, like I have here. Now, what were to happen if I split this up into smaller bits? So I have the circle, I have my center here. Now, what if think of this as a pizza. I was having pizza with a friend and I'm sharing this with them. So I cut the pizza down the middle like this. Ignore the bad drawing here. I'm cutting this pizza down the middle because I want to have half for me and another half for my friend here. So I've split this up, right? I have two what we call semicircles. So if we think about the area here, I have to consider if, for example, I wanted to find what area am I getting? Well, let's rub this out for now. This is a pizza slice, and let's say I have, I don't know, how big's a pizza usually? Let's just say this is 30 centimeters in diameter. Okay, so I've cut my pizza in half, and I want to find the area of the pizza that I'm getting. Once I've split this in half, what am I getting? Well, I can find the area of my whole circle. I already know how to do that, right? I just take my area, I do pi times my radius and square my radius. So what's my radius here? Well, my diameter is 30, so my radius is going to be half of 30. So that's going to be 15. So my radius from, say, here to here is 15 centimeters. So I'm going to do pi times 15 squared, and that's going to give me my whole pizza, right? That's going to give me my entire portion here. But I just want half of that. So what am I going to do? Well, I'm going to take what I have here and I'm going to divide it by 2, or I'm going to take half of it. So in my equation, I have, let me move this down. In my equation, I'm going to take my pi r squared, the area of my whole circle, and I'm just going to multiply that by the fraction that I've taken out. And in this case, that's going to be 1/2. Now let me just draw your attention to the two things I'm considering here that make up my equation. My thing here is my area of my whole circle, and my thing here is my portion. That's the portion of the circle I've cut out. So like this blue shaded area on the circle on the right. That's the portion that I get. I get 1/2 of this. So doing this mathematically, that just means taking the actual area and then just halving it. So I'm going to do pi times my radius squared times 1/2. And that's going to give me, when I put it in my calculator, that gives me to the nearest, to one decimal point, let's say, that gives me 3.4 centimeters squared. That's my portion of this half of a circle. So this was kind of easy because we just looked at taking half of the circle. But what if we had a bit of a trickier problem? So example 2 here. I have a sector, so a bit cut out of a whole circle. And I'll shift this over to this side. And the angle here is 120 degrees. And my radius is 2 meters. I want to find a way for me to find this portion, what 120 is going to be. Now, this sector here, all sectors are a portion of a whole circle. They're fractions of a whole, right? Think about when you have pizza with your family, right? You're taking the little pizza slices you get are actually sectors. They're portions that make up the whole pizza. You can tell I like pizza because I keep using that as an example. But what if I draw this entire circle here? Well, I have my, how am I going to show the portion of this whole? Well, my portion is going to be the 120 degrees, my angle. And what's the total angle of this revolution here, of my circle? Well, this hole is 360 degrees. Because that's what you remember from geometry. If I break up a circle into smaller bits, all of those angles will always add up to a revolution. They'll always add up to 360 degrees. Now, I want to find out, how can I express these bits of information as a portion? Well, I have a total of 360 degrees that make up my revolution. So let's just write here, portion. So I have 360 degrees that make up a whole, and only 120 of those degrees are shown in my sector. So this is a portion of 120 out of 360. That's the sector that I'm working with here. It's 120 3/60ths of a whole circle. So this little chunk here, that makes up my 120 3/60ths. And that's what I'm going to use to find the area of my sector. So I can say, I know the area of my circle, that's going to be always pi r squared. And I'm just going to take 120 3/60ths of that circle, of that area. Now, 120 3/60ths, we can actually simplify that because there's a number that goes into both top and bottom here. My 120, well, whoops, what have I done? Cool. 120 goes into 120 one time. And 120 goes into 360 three times. So 120 3/60ths, I can rewrite that as just 1/3. And that kind of makes life a little bit easier. This is an equivalent fraction. That is 1/3, which is far easier than writing 123/60ths. But if you do 123/60ths, if you're not bothered finding the equivalent fraction, that's okay. It'll give you the same answer. So here I'm going to do pi times 2 squared, my radius squared, times a third to find the portion of the sector. And when I pop that into my calculator, pi times 2 squared times a third, that gives me, to one decimal place, 4.2 meters squared. Cool. Okay, let's just do one more question and then we'll come up with a general rule for finding the area of my sector, something that we can apply to any sector. But I just want to do one more example, and this one's going to be slightly different. Okay, that's really badly drawn, but just bear with me. So I have 5 meters here, and I have 70 degrees. But the actual sector I'm looking for is this whole thing. So I want to first find what this angle is going to be, because that's the fraction of 360 that I'm looking for. Now I know that 70 plus my angle, I'll call that theta, equals 360. So I can find my theta by subtracting 70 from both sides. It's a pretty simple solution to way to solve an equation. Now, I'm just going to go through this quickly because I'm assuming none of this is new to you at this point, solving equations. So my angle value of my sector is 290 degrees. That's my portion of the whole here. So that's what I'm going to consider when I do my working out. Now, the area of a circle, I already know, is always going to be pi times r squared. And now, what portion of the whole are we trying to find here? Well, I have my sector takes up 290 degrees out of a possible 360. So the fraction that makes is 290 3/60ths. That is my portion. Like we had up here, we had an area of a whole circle and we had the portion that we multiply at the end. And when I get this, I'm just going to substitute in my radius. So I get pi times 5 squared times 290 on 360. And I'm going to put this into my calculator, see what I get. I have pi times 5 squared times 290 over 360. And to 2 decimal places, let's do this time. That gives us 63.27 meters squared. That is the area of not our whole circle, but the sector, the big chunk I've cut out of the whole. That is how we can approach these types of questions. Now, did we notice a pattern? Well, every single time we found the area of the whole circle and then we just multiplied that by whatever portion the angle made up, took up. So the general formula for finding the area of a circle, the area of a sector, is going to be pi r squared times whatever the angle of my sector is. I can think of this as theta over the 360 degrees, the revolution angle, revolution of my circle, 360 degrees. And my angle in the sector was always expressed as a fraction of a possible 360 degrees. And once again, in my two bits here, I can split this up into my area of my circle, of my whole circle, multiplied by my portion. That is how we can find the area of a sector. Thank you so much for watching, guys. I hope this gave you some of the intuition as to how we can find this. Now, once I know you understand it, you can just substitute straight into this formula. We took a bit of extra time just to hopefully give you some of the intuition here. We're looking at fractions. We're looking at portions of a whole. But that's it for today, for area of a sector, and I'll catch you in the next video.